Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 11th, 2025, just yesterday. The standout idea is echo training, which blends semantic learning with dynamic speech targets, so speech-to-speech models keep strong reasoning instead of getting pulled toward pronunciation quirks. The paper is titled EchoX Towards Mitigating Acoustic-Semantic Gap via Echo Training for Speech-to-Speech LLMs. And the implications for model training are quite significant. With about 6,000 hours of data, this paper reports advanced performance on spoken knowledge question answering and introduces streaming-friendly tokens and decoding. Also, the authors shared a GitHub repo. You'll find a clear README with key features and datasets, pre-trained EchoX 3B and 8B model links, setup steps, requirements, and quick start commands. There are inference and demo scripts, a Gradio app, sample assets, and model configs. The project uses an Apache 2.0 license. On Hugging Face, you'll find EchoX speech-to-speech LLMs with downloadable weights, a 3 billion and an 8 billion model, plus quick audio inference examples from the repo. While Figure 2 makes a simple point, EchoX reaches competitive web questions accuracy with far less speech data and fewer trainable parameters. The scatter uses log scales, which means each step multiplies rather than adds, so spacing reflects big differences in resources. EchoX sits low and left, signaling efficiency, while larger bubbles to the upper right need much more data or parameters. The takeaway is that echo training preserves reasoning quality without massive audio budgets. Figure 1 contrasts how training objectives shape behavior. Text models reward semantic closeness, so saying hi instead of hello remains acceptable because meaning matches. Speech models chase exact token acoustics, which punishes a correct idea if pronunciation diverges. EchoX inserts a text-to-codec pathway that generates pseudo-speech targets from semantic states, aligning acoustics with meaning and shrinking that gap. Alright, Table 1 gives the big picture. The team assembled about 6,194 hours of audio across 3 training stages, which supports speech understanding, text-to-codec mapping, and the final echo training. The table shows where each dataset fits because columns list task, size, duration, and stage. 2 entries used only partial samples, and Stage 3 counts only source speech. The mix includes ASR corpora, TTS synthesized dialogues, and spoken question answering sets. So Table 2 means EchoX delivers competitive speech-to-speech question answering, which signals that echo training preserves reasoning while generating audio. The table compares multiple systems across Llama questions, web questions, and Trivia QA, and reports an average score. EchoX 3B lands mid-pack, while EchoX 8B lifts the average, showing gains without massive data. This matters because comparable accuracy with smaller models suggests the acoustic-semantic gap is effectively narrowed. Wrapping up, 2 takeaways stand out. Echo training aligns acoustics with meaning by generating dynamic speech targets from semantic states, so reasoning stays strong. And unit language with streaming triggers delivers efficient, real-time speech generation with far less data. The broader implication is practical speech assistants that remain knowledgeable. That is it for the AI Research Roundup. I am Alex. Thanks for listening.